Okay, so just to continue with the theme of wood drying, I'm going to look at some of the defects that can occur due to wood drying, which obviously we try and avoid as much as possible. If we were to look at a stack of planks in a kiln, we might produce something like this. And between each stack we have stickers, which in this particular case would run in that direction. So these are the planks. I won't draw all the end grain, and so on and so forth. So we have a stack like that in the kiln. The stickers are running that way, so the airflow will go that way. And as I said, the idea with a kilning operation is to ensure that the airflow, the temperature and the relative humidity of the air are just correct, so that the rate at which the wood dries out is not too fast on the surface, so that there's enough time for the water inside the wood to diffuse to the surface, so it evaporates at the same rate at which it diffuses. Not possible to get it exactly right, but we attempt to get it as near to that ideal condition as possible by varying the kilning conditions as time goes on. Obviously, as the wood gets drier, we can afford to reduce the relative humidity of the air, and we can afford to increase the temperature. But certainly at the beginning of this process, we have to be extremely careful how the wood dries out. Now, for quite some time, the moisture content of this wood will be at the green moisture content, and by green moisture content we mean above the fibre saturation point. And the fibre saturation point, for the purposes of this discussion, is something of the order of 30% moisture content. So that's based on the dry mass of wood. So that would be 30 grams of moisture in 100 grams of wood, a fibre saturation point of 30%. Over time, as I say, we're going to get to the point where we reach fibre saturation point, and when that occurs, we're going to start taking moisture out of the cell wall. And when that happens, we are going to have the dimensions of the wood changing. And when the dimensions of the wood change, we are now in a regime where we can have distortion occurring. And that's something we want to avoid. And we can avoid, or at least minimize distortion if, first of all, we follow the kiln schedule very carefully, and we make sure that all the wood that's stacked in the kiln has the same dimensions, is from the same species, and is as similar, each piece is as similar to every other piece as is possible, because then that schedule we can apply to that particular type of wood. If we put in mixed dimensions or mixed species, we're just going to have trouble. So we have to be extremely careful about that. Now, the types of distortions that we can have in wood, we can have twist, where the wood, showing a slightly exaggerated version here, where the wood is actually inverted. So the wood is twisted like that. That's one particular type of distortion. The wood can cup. This can be quite common, particularly if the wood is not sawn on the quarter. Then wood that has this sort of tangential face here can be subjected to cupping, and that may even happen in service. If you take wood that has been drying and hasn't shown any cupping during the drying process, you put it into service, it may dry out more in the house, maybe you're using it for a floorboard, and then that cupping will become apparent. This is one of the reasons why wood has to be dried to the correct moisture content for the application it's going to use for. So for something for interior applications, we want a moisture content of around about 12%. For interior use, 20% is acceptable for exterior use. Another type of distortion that we can have is bow. Not quite so serious. Again, a rather exaggerated example here, but the wood is now bent in that sense. That's a bit easier to deal with because if you've got a plank like that, maybe it's a floorboard or a piece of cladding, you can just nail that into place and that can be taken out, that distortion can be taken out. So that's not quite so serious. Rather more serious is this type of distortion. which is known as spring. So the wood is now distorted in that sense. That's not so easy to take out. Depends how much is there, but that can be quite a serious distortion if it's too excessive. Obviously you want to try and avoid these as much as possible, but these are all consequences of not having the correct kiln schedule, or just simply consequences of the wood is going to contain mixtures of heartwood, sapwood, juvenile wood, compression wood, and just from different trees. There are all sorts of issues that arise because of the grain angles, presence of knots, all these sorts of things. So wood is a variable material. It's very hard to avoid some sort of drying degrade. The question is, at the end of the drying process, is how acceptable is any of this type of distortion? And that's one of the reasons that at the end of the process we then have to go through a selection process where we have to decide where that wood can be used, or indeed whether that wood is acceptable for service or not. Okay, so these are the different types of distortion that you can get when you dry wood incorrectly. In some sense it's impossible to avoid some distortion. It's a question of how serious it is, and what you want to do with wood drying is you want to minimise the reject rate, because every piece of wood that you reject at the end of the drying process, because one of these types of distortion or several of them are too much to be acceptable in service, that's money wasted. You're not going to get that money back. You'll have to chip that wood. So probably the most serious of these is twist and spring, because these are the ones that are more difficult to deal with in service. Bow is quite common but relatively easily dealt with, because with something like a floorboard you can just nail that flat and that will pretty much remove that distortion. And cupping, hard to avoid in practice. Even if you dry the wood correctly and it doesn't display this in service, it may be that if it hasn't been dried to a low enough moisture content for internal use, or too low a moisture content for internal use, when that wood equilibrates to its internal environment, it may display cupping in service. We normally dry wood to about 12% for internal use. And the other thing that we want to avoid as well, of course, is splitting. And this can quite commonly happen with wood where you're looking at the end grain like that, and we have the grain pattern running that way, and we may find, because the, oops, nearly fell over then, because the external, the longitudinal pathway for water to come out is so much faster than the other directions, we can actually have very fast drying of the end part of the wood, and that can cause splitting, and that is also something that can lose value in the timber.